In this video, we take a look at how the key indicators categories define the way in which HOPEX automatically computes the indicator status. So the objective of this video is to teach you what is the logic behind the key indicators computation. So in the standard versions, key indicators categories can be of 4 types. So first one is the standard category, which is commonly the most frequently used. This type of key indicators are those for which the higher threshold determines the business objective. Then we have the reverse category, which is the opposite of the standard. For these type of key indicators, the lower threshold determines the business objective. We then have accepted values category. In this case, the indicator lower and higher thresholds determine the interval of accepted values and therefore the business objective. And finally, we have the opposite of the accepted values category, which is the rejected values category, for which lower and higher thresholds determine the interval of not accepted values. So every key indicator category has an associated macro, which automatically computes the indicator status. And this macro is referenced by an intermediate object, which is called key indicator interpretation logic. The key indicator interpretation logic also contains the list of statuses that the indicator of the associated category can be in. To understand this graphically, as we can see on the slide, every key indicator category is associated to one single key indicator interpretation logic, which contains a list of indicator statuses and the indicator status computation macro. So by default, when the user creates a new key indicator, this will automatically use the existing category interpretation logic, which is provided out of the box. For every category, HOPEX provides one single interpretation logic. And if needed, however, the user can create his proper interpretation logic for a specific category. So if an indicator category has more than one interpretation logic available, the key indicator creation wizard will ask the user which one should be used in order to compute the indicator status. Let's now take a look at the different indicator categories and how the macro, the associated macro, computes the key indicator status. For key indicators of category standard, these are indicators where the business objective is typically identified by the higher threshold. This means that the closer the key indicator value is to the higher threshold, the better it is. In other words, the key indicator status improves as its value increases. Let's take a look at a practical example. So this is a representation of a key indicator whose lower threshold is identified by the line low and the higher threshold is identified by the line high. There is then another parameter m, which is simply given by the high plus low divided by 2. So is the mean between high and low. As we can see here, the indicator of type of category standard will be in a failed status whenever its value is below the lower threshold, and starting from the lower threshold up to going up to the higher threshold, the status moves from critical, unsatisfactory, warning, and operational. As we can see in the image, the status of the indicator in the algorithm provided by default within HOPEX becomes operational before reaching the higher threshold. Since the higher threshold is the optimal scenario, but as soon as we are quite close to the higher threshold, the key indicator is already considered as into the operational status. To have a better understanding of how these intervals, operational, warning, unsatisfactory, critical, and failed, are computed, the slide also proposes the mathematical formulas that have been used. In addition to the statuses displayed in the image on the left, we remind that there is another status, unknown, which is the status in which a key indicator is whenever no values exist, or the monitored interval hasn't finished yet. So we have two scenarios. Either the key indicator has no recorded value whatsoever, so its status is obviously unknown, or let's pretend that we are using a key indicator with a monthly aggregation of its values. We create this indicator in March, and we want to take a look at the indicator status on March 15th. Even if there might be some existing indicator values, for instance, let's say one indicator value recorded on March the 7th, still March hasn't finished yet, so the aggregation of the values recorded in March could not be carried out, and so there are no useful values for our indicator to compute its status. In case of indicators of category reverse, these indicators are those where the business objective is typically defined by the lower threshold. This means that the closer the key indicator value is to the lower threshold, the better it is. In other words, the key indicator status improves as its value decreases. If you take again a look at the previous example, as we can see, the indicator status is failed for all values above the higher threshold, and starting from the higher threshold going towards the lower threshold, the indicator status moves from critical to unsatisfactory, warning, and finally operational. Again, as you can see in this representation, the indicator will move into a green status, the operational, slightly before reaching the lower threshold, which is considered to be the optimal value for the indicator. Every value smaller than the lower threshold will still provide an operational status for our key risk indicator. Again, if needed, this slide provides a details about the mathematical operations behind the computation of the different status for our indicator. Let's now consider the category of accepted values. Key indicators of category accepted values are those where the business objective is typically defined by an interval of values, which is identified by lower and higher threshold, and this set of values is referred to as accepted values. This means that the closer the key indicator value gets to the middle of the set of accepted values, the better it is. In other words, the key indicator status improves the more its value gets closer to the middle of the accepted value set. Again, if we take a look at the previous example, we have here a key indicator of type accepted values, and we can observe that all values outside of the accepted value set, which is defined by lower and higher threshold, put the key indicator into a failed status. Then, the closer we go to the middle of the set of accepted values identified by the parameter m, the closer we get to the operational status. So we move from, if we consider the higher threshold, we move from failed status to critical, unsatisfactory, warning, and then operational. If we continue decreasing the value of the indicator, it means we are moving away from M, so the status will degrade from operational to warning, unsatisfactory, critical, and then failed. Again, if needed, this slide presents the detailed mathematical formula which determine the sets of statuses displayed on this example. And last category, rejected values. Key indicators of category rejected values are those where the business objective is typically defined by values outside of an interval, which is identified by lower and higher threshold. And this interval is referred to as rejected values. This means that the more the key indicator value moves away from the set of rejected values, the better it is. In other words, the key indicator status improves the more its value moves away from the set of rejected values. Again, we have the usual example, and here, as you can see, the status of the key indicator is failed whenever the indicator value is within the set of rejected values. So within the set which belongs of values which are bigger than the lower threshold and smaller than the higher threshold. Then, the more we move away from this set, for instance, the more we get values which are higher, bigger than the higher threshold, the better will be for the indicator. So its status will improve from critical to unsatisfactory, warning, and finally operational. Same goes on the other way around. So the more the value of the indicator becomes smaller than the lower threshold, better it is for the indicator status. And as done for the other categories, also in this case, we provide detailed information regarding the mathematical formulas implemented to compute the status of the indicator for the rejected values category.